Hello, in this section we will be going over 2.1 in the IGCSE Marine syllabus, which is water cycle, and starts here with particle theory, or what's called the kinetic theory of water molecules. So it's a little bit of basic physics and chemistry. As always, when you look at an IGCSE Cambridge subject, always look at the syllabus first. You can see it here on the screen, so you know exactly what it is Cambridge wants you to learn on this particular subject. So without this becoming a physics class, it's important to remember that in our current view of the world, everything is made of atoms. I know that atoms are also made of protons, neutrons and electrons, and so they're made out of quarks and so on. But everything is made of atoms, and those atoms combine together for molecules. The particle theory is the idea that all these tiny molecules, particles, are constantly moving. They are not standing still. And how much they are moving, how much they are vibrating, will determine what shape they're in, what state they're in. And we look at three states here in this course here. We have the solid phase, where everything locked together. We have the liquid phase, and then we have the gas phase. And we will be going a little bit more into detail about that in the following slides. So, if we start with the case of water, since it's been marine science, we start with the solid phase, that's our ice. In our ice, our molecules are packed closely together. They are not moving very much, just vibrating against each other. It also means that my ice has now a fixed shape. It has a shape of the ice cube or whatever it is into, because all the molecules have been held into place. As we add more heat, our ice will melt and now turn to liquid water. Our liquid water, the molecules are still closely packed together, but now they can float past each other, they can vibrate, and now they take the shape of the container. I pour them in. They pour half a glass of water, they fill up half that glass of water. If I add more energy, I start heating the water, and it turns to water vapor, it turns to gas phase. As it does so, the particle now moves far away from each other. They're not really bound together. There's a lot of space for them to move. And it takes the shape of whatever container the gas can be in. It fills the volume of the space available, and it will spread it out to a large volume. Now, if we look at water going from ice to liquid, we here have a graph that kind of shows the different phases. At the point A, we still have a solid, which means we have ice. As we now increase the temperature, we will see that the temperature of the ice will start climbing until about we get to the point of B. From B to C, over time, we see no real change in temperature because we are now at the melting point. While a substance is melting, the temperature stops increasing because the energy transfer to separate the particles enough to move past each other, well, they gain latent heat during this melting. This leveling off of the temperatures that occurs as a solid is melting gives many materials a well-defined melting point. For water, fresh water, it's 0 degrees Celsius. So from B to C, we see we have the melting point, and then the temperature starts increasing again as time moves on. And then when we get to D, we get to the same thing. We get to the boiling point, and the same thing will happen again. Be aware that water will start evaporating before it gets to the boiling point. Water can evaporate as soon as it's a liquid. Also be aware that some substances go straight from the solid to the gas, CO2, dry ice being an important one here. But the important thing is that using the right apparatus, we can then measure our melting point and our boiling point, and this can also give us an idea of the substance we're working with, or how pure, if it's water, how pure our water is. Lastly, we'll look at diffusion. Particle theory is a good way to explain diffusion and how different substances mix with each other. The particles in the liquid are always moving. So although you can't see it here, all the water molecules here are still moving, which can help explain what happens if I have my cold water here and I add just a little bit of food dye to it. And quickly, we can see the food dye starts spreading everywhere. And what we see here is diffusion. The particles, they move around by random, but they'll tend to move from a place of a higher concentration to a lower concentration. It's not that they know where the high or the low concentration is, they just have a random movement, and the warmer my water is, the faster diffusion will be. So diffusion is movement of particles by random inside my water. So understanding condensation, evaporation, all these things when water changes state from solid to liquid and liquid to gas is important to understand the water cycle. Our planet is a blue planet, and the movement of water around on our planet is a huge part of what is marine science. There are of course many things that has an influence on it, and one of the main things is temperature. As temperature goes up, we have more evaporation from the land, and we have more transpiration from the plants, which leads to water vapor going into the air. Then, as water evaporates, it rises. Sometimes the rising air will cool. At this point, the water vapor will start condensating into clouds. And when these form into water droplets, then they can rain down as rain, snow, or hail. Much of the rain will fall straight back into the seas and oceans. However, some clouds will move over land, and the rain or snow from these clouds will fall onto the land, either as water, fresh water, or as snow. Eventually, that fresh water or snow will then run into lakes and rivers, and eventually that will then run back into the ocean, and we'll have surface runoff, which is water flowing over land to return to the rivers and the ocean, which brings nutrients back into the ocean. Some water will also go into a groundwater, but that will also eventually leak back into the ocean.